determine principal stress. Okay, principal stress. And more important, and maximum shearing stress. Okay. Now, there will be three conditions that I'm going to show. Okay. So below examples.
Sorry, Eugene, could you go to the image of the end plane for a second? Thank you.
Welcome. So below example is based on the elements have 0 shearing stress or shearing stresses, and okay, oriented in the principal stress direction. Okay, so whatever I'm going to show you, okay, shearing stress is equal to 0, and they are all oriented in its principal stress. Okay, so let's look at condition number 1. Okay, I'm going to move. Okay. So condition number 1. Okay, condition number 1, where you have stress Z is equal to 0. Okay, and stress X is greater than stress Y, and both are positive. Okay. Okay, so the transformation is still the same. Okay, I'm not going to draw the transformation again and again. So this is stress X, stress Y, stress Z is equal to 0. Okay, so I will put down this as point X, point Y, and point Z, right? So stress X is greater than stress Y. Okay, just to let you know. So we are going to draw. I'm only going to focus. I mean, for this one, I just need to draw the positive. Okay, there's no compression. Right. Yeah, this is big enough. Yeah. So this is normal stress, shearing stress. Okay, clockwise rotation, anti-clockwise rotation. So this is our stress X. Okay, so I'm going to make it quite as big as I can. Okay, so this is our stress X line. This is our stress Y line. Hold on. Yep, so this is our stress Y line. And over here, this is our stress Z line. Okay, so we know that this is our X, and this is our Y, and this is our Z. Now, this is a good example of why you cannot rely on 2D Mohr circle. Okay, if we only draw in 2D, we only draw in what? XY plane, right? Right, we draw in our XY plane. This is our 2D Mohr circle, right? Right. So this circle over here is for our X, Y plane, right? This is for our XY plane. And then when you look at here, right? When you draw this, okay, so you pick material, right? You pick a material. So let me use black one. We put a material based on here, right? So the distance from here to here. Come on, go down. Okay, this is the max. The distance from here to here is this is your tau max, right? Tau max in the xy plane, right? That is your maximum, right? And then, and this is your so-called your in plane, right? Xy is your in plane. If you just do 2D Mohr circle over here, you are in trouble, okay? And I'll show you why later you're in trouble. So you pick your material based on the tau max value in the xy plane, okay? Your tau max value. So you select your material, okay? But it failed based on the tau max. You let's say choose your material based on the tau max, it will fail, okay? And you say, oh shoot, okay? But by accident, it still happened to work. I say it again, by accident. Later on, I will explain what do I mean by accident. Then the next circle you can draw, okay, the next circle that we can draw is this one. So touching the YZ point. Okay, I want you to observe, okay? So this circle over here is for your YZ plane. So I'll write this. This is in plane. Okay, that's our in plane. And then when you construct this, this is your. This is your. Is this orange? Dark green. Okay, so this is your out of plane. So now you realize, oops a daisy, right? Why oops a daisy? Because now this is your tau max. Right, this is your tau max for your YZ plane. Right, that's your tau max for your YZ plane, and it's out of what? Out of plane. And you realize now where the trouble now is. The trouble is this now, right? The trouble is the maximum stress is not the in plane, and it's at the what? Out of plane. So if you were to just do 2D Mohr circle, and if your material is sensitive to shear, you're done. You're game over, man. Your structure will fail in shear. Okay. So, but we have one more circle to draw. Okay, we have one more circle to draw. Now, before I will say this. Now, this is our what? This is our YZ plane. So this is also out of plane. Now, you guys now know what is in plane and out of plane. But do you all know how we label this? Why is this XY plane? Anyone?
Professor, is it YZ or XZ?
Oh, you're right. He knows now. He sees the pattern. So this is, thank you. Okay, this is our XZ plane. So Chip Zibiri knows now. Okay. Now, do you all realize how it's labeled? This is XY plane because it touches the what? The Y and the X point. Okay. And then the next one is our YZ plane because it touches the Y and the what? Z plane. And finally, the last one is our XZ plane because it touches the X point and the Z point when we construct the circle. Okay. So that's how it's. Now, what you realize now, okay, is this. The out of plane is the maximum shear of the entire structure. Okay, so this is equal to our this is equal to our shear in the XZ or maximum, which is XZ, and is equal to our maximum. Okay, right, and this is also equal to our tau max ZX. Is the same thing, right? And this is equal to, the formula is equal to stress X divided by 2. Okay. Now, this is only true, okay, stress X divided by 2. This is only true because stress max, normal stress max is equal to our stress X, okay? And stress mean is equal to our stress in the Z direction, because Z is 0, right? And is equal to what? 0, okay? So this is one scenario. That's why this is a good example, okay? Especially when we design our structure, we have to look at the shearing stress property of the material also. Because when material fail, it usually fail in what? In shear for ductile material. For brittle material, it is usually fail when there's shear. Okay? So you have to be very, very observant, aware in this matter. Okay, that's why 2D Mohr circle is just to construct the location of the stresses on the element. It's 3D Mohr circle that you select your material from. Okay, like you look at the use strength from a material handbook, you have to imply 3D Mohr circle. Or not, we are done. Okay, right. Condition number 1. Then I'm going to give you condition number 2. Okay, so condition number 2. Okay, condition number 2 is when stress Z is equal to 0, okay, and stress X is positive, stress Y is equal to negative. Okay, so how does this look like? So I'm going to copy this. Yeah, I'm going to bring this here. All right, we're going to bring this here. 4 years ago, I was an expert witness in a stress state condition, okay, where the principal engineer got this wrong, and I have to show this in court. It's not easy, okay? it brings back memory, okay? Where the judge is, the last time he did physics was in high school, okay? I took about like 4 hours from 2D, just 2D Mohr circle, okay? Yeah. I took, about 4 hours. You don't want to know how long is 3D, okay? I was representing the Queen's Court, but yeah. That's what I want to train you guys on, being expert witness, right? The hourly rate is $250. I was a cheap labor. The lawyer's fee was $900 an hour, just to let you know. Right. Some of you will say I'm in the wrong field. I think we are in the wrong field. Right. Okay. So now the stress Z is 0, right? Okay. So we know that this is our Z point. Okay. So from here, this is our stress X, positive, and over the other end, this is our stress Y. Okay, and we know that this is our point X, and this is our point Y. Okay, so we draw our circles. Okay, so I'm just going to draw the circle, and I'll tell you where's the maximum stress of the entire. So for this case, right, okay, let's start like before. Okay, so we're going to draw 2D Mohr circle first, right? 2D Mohr circle means the XY plane. Okay, so 2D Mohr circle. So this is our first circle. So 2, 4, 6, 9, 2, 4, 4.5.